Okay, good afternoon. I'm Robert Pająk. I come from Krakow in Poland, and today I'm going to talk about creating build pipelines for a Go project. Regarding questions, please, if possible, keep it at the end. I think that it's also okay if you put it, I don't know, on Slack, on chat, or whatever. If you do not want to speak out, I hope that the organizers will help me and read them aloud at the end. Right? Okay. Let's go further then. Here is the agenda. First, I will tell a few words about myself. Then I will demonstrate 3 tools that I use for automating build pipelines for Go projects. And at the end, I'm going to share with you my subjective conclusions. I stress the word subjective. Before I jump into details, let me introduce myself so I give you more context on this presentation. On the left side, you can see my family's pandemic photo, but let's go to business. Since studies, I have been mostly using Windows, C#, SQL Server, PowerShell. Doesn't feel like anything Go related. And since 2 years, I started to develop in Go. In the beginning, I was creating new REST API and QConsumer microservices. Now I develop a multi-platform agent. I started to favor Go over C# because of its simplicity, minimalism, build time, testing package. Generally, it's like it's simple design. And at last, I try to follow XP values, principles, and practices. I do a lot of automation and use TD as much possible, but of course, always whenever I think it makes sense. In enterprise software development, you usually need something more than Go FMT or Go test to run unit test. You want to have some common build pipeline for sake of continuous integration. So you want to use the same build pipeline usually like your other colleagues, or you want to use the same stuff on your continuous integration server. When we started creating the REST API microservice, a more experienced Go developer created the repository with boilerplate code for us, and it included a build pipeline done via makefiles. After talking with other people, also from our meetup and inside and outside of our company, I think that I can say that currently makefile is the de facto standard for automating builds in Go. Without further ado, let me present some simplistic example. And I will go to the browser. So for the purposes of this presentation, I have created a little repository which will demonstrate a very simple pipeline using Make, Mage, and taskflow. And I will go just one by one and try to describe some details. The build pipeline called all will be very simple. It contains just 3 steps. The first one will be clean. It will just remove files creating during the build, and it will log which files have been removed and which have failed to be removed. FMT will simply run Go FMT to format the code, but it will be like imported in a way that it could be in theory reused by other projects in your organization, your company. And the last one, test, will run the unit test and generate the HTML code coverage report, even if some tests fail. Let me jump into VS Code. So before maybe showing the make files and how make works, just I will demonstrate the Go code. So you see here a very sophisticated example of an exported function called foo, which just returns bar, and a function that and a test unit test that expects it to return foo. So obviously, if I run Go test, this function will fail. So for those who are familiar with Make, when you here, I will just demonstrate like how Makefile is implemented in this repository by just showing from the outside. So before going to details, I will just use it for a while. So if I type make, I see here the available targets and their descriptions. And if I use the all target, I will see the output that it had run a remove force verbose for all files that are starting with coverage, and that it has to remove those two files, that it executed gofmt, then it executed go test with the race detector, and then it also generated the HTML report, which we can see here, the output. And the test has failed, of course. Okay, so maybe a few words about Make. So Make by default, if you use type Make like that, runs the default or the default target from the Make file. So by convention, it tries to find it finds or tries to find a file called Makefile, and then it takes the description of the tasks and run the one that has been specified. So here, you can see the declaration of the build pipeline. We have a target called all with a command build pipeline, and it has the dependencies to clean FMT and test targets. So whenever we run all, these three targets should be also executed. Clean target is just implemented to run RM FVV coverage to remove the files, and the test target is implemented in a way that we have a temporary variable to remember the exit code of the go test. We assign it here, and then we run go test cover to generate the HTML report, and then we exit with this with the exit code from the go test. This is done in a way so that we always get the HTML report, even though the test will fail here. The last line, which is like I've described, is include common go and make here. So this is a way how you could reuse some common stuff across other projects using Makefile. Usually, I have seen that people are simply using Git submodules or Git subtrees, or they are simply copy pasting some common file between repositories. So here is an example in theory reusable Makefile that was used here. So we assigned that the default shell will be bash. So to make sure that it should work everywhere, the same shell will be used in different environments. The default goal will be help. And here we have the implementation of a magical help target, which basically parses the make files, tries to find all the targets that have a magic command with two hashes, and they're being printed, like that. Also, there's another helper function called print-target, which basically just prints the target, which the name of the target that is currently executed. So a magic function that does such thing. And at last, we see this reusable target called FMT, which runs gofmt. Okay, so basically that's it. It's very simple, as I told. And if you want more details regarding Make, its possibilities, documentation, I encourage you to go to this website and read more. Okay, so now my experience report regarding Make, the problems which I had. Basically, because of my background, I had to learn Go, Make, and Bash at the same time, and it was quite disappointing for me. Especially when learning Make, I looked at an example Go skeleton application, which has the biggest amount of stars. It has more than 2,000. And when I look at its Make file, basically I would think that lots, almost all features of Make are used here, and it was for me, oh, what is going on here? It was very hard to understand what's going on here. And if something like that is used as template, it basically shocked me, and that it's so popular. And I like to understand what's going on. Also, using even Make, Bash, and even Go on Windows is kind of problematic. I would not say that it's hard to install Make and Bash on Windows, but it's not something that usually people do. And because of that, I switched to use Ubuntu as my development environment. Besides, I also know that SREs are writing Go apps instead of Bash scripts for reasons like compatibility. So if you use Bash scripts, you often rely on other programs like sed, less, wget, curl, and other stuff, and you often do not control its versions. So you can have the same Bash script which can run different in different versions of Ubuntu, for example. After a few months, after learning the most important stuff in Go, Bash, and Make, I decided to take a look at Mage to check if it would solve or like address some of my problems or things that I didn't like using Make and Bash. And I wanted also to verify if it will be something that will make it easier for newcomers to get into Go projects. What is Mage, if someone does not know? So Mage is a make-like tool created in Go, and basically you write Go functions, and Mage automatically uses them as runnable targets. Again, demo time. So right now I will switch into another folder, which contains the same example, so the same Go code here, but right now I'll show how it works for Mage. So there are two versions of using or installing Mage. One is just installing it like on bare metal using Go install, for example, and the second is using it as a Go module and have a very small application like that. So because I'm using Go modules, I prefer this approach, and I also make sure that the same version is used across other teammates. So to run Mage, I just type go run Mage Go, and you have a similar output. Here are the available targets. And if I run go run Mage Go all, I get the information that running Go test race have failed with exit code 1. So I do not have any details. I just have information that it had failed. To get more information, I need to run Mage in verbose mode. Then I have a very similar output to the one that we have seen for Makefile. So we have information that we are running target all, the dependency is being run, and that what it had removed, etc., etc. So basically, now we have a similar output. Okay. Now I will show you how the targets are being implemented. So Mage requires to create a file called Mage file by convention. If you want to, like you had this make file in for Mage requires a file called Mage file Go, or basically any file, but it requires you to have build tags with Mage. And here we have the implementation of all target, which depends on clean, FMT, and test targets. So you can see you just need to implement an exported function with a command, and Mage just magically parses this stuff and uses them as targets. Here is the implementation for clean. So instead of using RM, we just have a Go code which finds all files which are matching this pattern and tries to remove each file. And if it has succeeded to remove, it just prints it. If it failed, it assigns the temporary error value to a variable, and at the end it returns the error, if any, has been assigned here. Here's the implementation of the test target. So we are executing both commands here, and if any of them failed, we just return. If nothing failed, we just return nil. The last thing which I have not, the last thing, this reusability aspect. For Mage, you can take advantage of Go packages or even Go modules. So you could create a shared Go repository with targets. So here we have it in theory reusable target, which is called FMT and runs Go FMT. So this code here is very simple. And to use it, you just need to import it. It's registered here as the dependency. And in order to tell Mage that it should parse this stuff, you need to add this as magical command Mage import. If you want to know more about Mage, I highly encourage you to read their docs on magefire.org. And I also, if you just want to even not even know more, if you want to use it, I really encourage you to read it, because if you do not understand how it works or how to make some stuff, you may not understand what's going on wrong. Okay, let me right now go to some conclusions, my experience report. So my main concern regarding Mage is that, like the name even says, it's magical. So the target discovery, which requires build tags, and Mage, which is generating Go application under the hood to run the stuff, makes debugging very hard. And also because of the build tags, it causes problem in most of the IDE, for example, in VS Code. So I do not have IntelliSense, because you have multiple packages in one directory. Moreover, I do not like the magical import comments. I find them simply hacky. The other stuff which I have not showed, but which also had, because of it, I also had lost some time, is that dependencies, when you're using, I think it was depth function, are run by default as in parallel, and their output, when they're printed in the stdout, will be mixed up. There's no synchronization when the output is being dumped. The last thing which I didn't like is the sh package, which is contains helper functions to run applications. Shocked me because of the number of functions that it possesses. So I think all of these here, except this one function and this one, are the ones that you can use to run some application like GoFMT, GoRun, or whatever. And basically, after this experience of using it, just let me close it. I thought that something is wrong and maybe something could be done easier. It took me more than 1 year to come up with something. And what was helping me was that in parallel, I'm also maintaining a Go repository template, which you can see here. And basically it contains some stuff, and one of each, which is quite obvious, is build automation. So it uses Make. For some time it was using Mage, and yeah. And without it, probably I wouldn't go so far. So when building taskflow, or when thinking about it, I wanted to create something that will feel more idiomatic, like Go idiomatic for me. Something that resembles Go, its tools, standard library. I wanted something simple to use, something very minimalistic. I wanted it to feel familiar with other stuff that I'm used to in Go. So after a few long nights, I thought that I will come inspiration from the Go standard library packages, and instead of creating a framework, I just want to have a little library which I can just use to write a small application and run it via GoRun. And I thought that the tasks, the implementation of the tasks, should look similar to unit tests. So I took the inspiration of the testing package, and the registration of the tasks could be then similar to registering HTTP handlers in HTTP package. And at last, parsing ours should be leveraging the Flex package. Let me show you how the build pipeline would look like when I would implement it using taskflow. So again, let me go back to VS Code. I'm changing the directory. So right now I have the build pipeline in a build folder directory. So in order to run taskflow, I just need to type go run build. And we have an information that the no task has been provided and information about usage. And here we have also the information what tasks are available. So if I run go run and I type all, the tests are, everything is run, but we have only the output from the task which failed. So we have only the output from from running the tests and the information that the test coverage has been failed. So when I'm developing, it's okay. I'm just interested in anything that failed and also information how much it took. If I want to have everything, all information, I run it in verbose mode, and it works similarly like testing package. The output is like streamed. So here we are having the output of all tasks, and also even the output here, I tried to make it similar to what we have in testing package. So I have these prefixes like that. So here are the prefixes for testing package, and here's the one that I have created for taskflow. Okay, so this is like the usage perspective. Now I'm going to the implementation. So here we have the function, like not the function, sorry, the main Go file, and we are using it as a library, which means we are creating a struct named tasks, and we are registering clean, FMT, and test tasks, and then at the end we are creating a task which is a pipeline. We just have the dependencies of all of these three tasks. The implementation of the tasks is here. So we are returning a struct which consists a name description and a function, which a command. So here you can see the implementation of removing the files. So it looks extremely similar to the one that we have seen for Mage. The difference is the error reporting. Instead of returning error, we just use tf_error_f functions, tf_fatal_f functions, and tf_log_f functions. So the API is like the same as for testing package. And also thanks to it, you can reuse your favorite assertion libraries like Testify if you want, but basically you can try to reuse some code that you use for testing purposes. And here's the implementation of the task command. We have a function called cmd, which returns the exec command. So instead, which already have some fields prepared to be run for taskflow. So instead of having like this 8 or 10 functions or methods to execute processes, I just leverage the standard library just to get the command. And if I want just to run it, I just run it, check the error code, and we are reporting potential errors. And what about reusability of other stuff? So similarly to Mage, we can just have another package, and the only thing that we need to do is just to register it, like here. So we have a FMT, Go FMT, and here we have a little, the only like second helper function which just returns a command which executes only a single command, which from my experience is the most common stuff which you do when creating build pipelines. Usually just execute one program. Okay, probably I have forgotten about some stuff. Okay, maybe one more stuff. The advantage also of taskflow is that you can debug it or write tests quite easily. Because of the Mage design, it's very hard, and because it creates some application under the hood, it's hard to debug. Here, there's no problems like this. You can just put a breakpoint. If you have this launch, you can have your launch configuration or even run dwell from the command line however you want. You can put, for example, here that I want to run like all target, put some breakpoint here. I can run debugger and it's working. So for guys who want to understand what's going on, and if someone has something complex, it's possible to debug. And what it's more, is also very easy to write unit tests, because I have also created a little struct to run just a single command and just go to information if something have failed. So if you want just to debug one particular task, you can just create an instance of the runner and just run this task. And the same stuff, you can just debug this test here and just make sure that I have not removed the breakpoint here. We can just debug it, and we can just check interactively what's going on. Okay, 25 minutes passed. Let me finish the demo. The last thing, that if you want more information, more docs, go into the GitHub page. You can start some discussion here. You can find me. You can go look at the Go doc. It has also additional examples. And let's go back to the presentation. Time for some conclusions. Make. I think that Make is still probably the most powerful tool, and it's very concise. Make is also language agnostic, and because of that, you can also use it for other projects or even no Go repositories. So even though I was presenting Mage and task file at work, I still use Make, and also because I use it for also automating stuff like setting up local Kubernetes cluster, doing some protocol validation, and automating other stuff which is not Go related. And if you have any problems, if you have some complex stuff, you're not forced to write bash. You can always write little programs in Go and just execute Go run in your make targets. There is nothing bad in it, and highly encouraged to do it for complex stuff. And basically, regarding make, I do not think it is bad. I think that it's just complex, and probably, at least for me, it's more complex than Go. What about Mage? It requires only Go, so it will run everywhere and you can leverage your Go experience. It has quite a good community. According to GitHub, it has 50 contributors. It has more than 2,000 stars. And real enterprise projects are using it. And I guess that most developers are not so complaining like me and are okay with its design. Regarding taskflow, it also requires only Go, but it is built like a library instead of a framework or tool approach. And I think that I have this less is more philosophy. Oh, sorry. And basically, it's an experiment to make something simpler and more approachable. I hope that every Go developer can learn it in less than an hour, maybe even in dozen of minutes. Yet I think that it's still powerful and that it can scale, as it should be very easy to extend its functionalities, and creating common build tasks or pipelines and debugging all the things like that should be easy. Do I have any plans for future? First of all, I'm waiting for feedback. I want to address all the stuff based on feedback. The only thing that comes to my mind regarding current state, but because I first want to get some feedbacks, is I'm totally aware that some unit tests are there missing. I was implementing it during nights usually, and probably I will need to refactor the task flow main function. And basically, the thing that I was missing both using Mage and Make for complex stuff, I think it will be good to add some additional flag to output a dependency tree and to uh, have something like that. So when you're getting into a new project, instead of just listing all of the targets, when there's a new developer, he could also understand the relation, the dependencies between all tasks. Okay, and I would love to get feedback from you, both regarding the presentation, if it was enough interesting, if you liked it or not, but also regarding task flow and my conclusions. If you think that task flow is worth maintaining, something should be changed, you want to try it, maybe you think it's harmful, it's bad, I should archive it, do not hesitate to tell me. I'm really an open person, and I think that without giving me any feedback, my nights will be wasted. And I encourage you to take a look at the examples docs yourself, play with it, compare, and again, feedback, please. Here are some hyperlinks and contact information. Thank you very much for your attention and your time. Maybe anyone has a question right now.